Okay, everyone, so graphing logarithms, and this is really quite simple. Um, if you remember what we're dealing with from exponents, okay, remember to stop my video so I don't take up any more space here. All right, so I'm going to call this is 6.3. I'm going to call it C. So this is graphing. Okay, and so we always have parent functions, right? Okay, so when we think about the parent function to a logarithmic, okay, remember that you're thinking of it's just the inverse, friends. Remember that y is equal to log bx is just the inverse of the growth function. Okay, here's what I want you to think of though. Okay, I can put this in as an exponent. So what is my base? Well, my base is b to the y power equals x. Okay, this is why when we plug in our values for x and y, we're going to plug our favorite 0, 1 in for the y values, not for the x values. Why? Because remember when we always found the inverse, we flip-flopped, okay? So let me show you what I mean by this. So let's do y is equal to 2 to the x power, okay? Growth, you agree with that? All right, well, let's do our values. 0 and 1, right? 2 to the 0 power is 1, 2 to the first power is 2. So I go ahead, I graph 0, 1, I graph 1, 2, and I graph my line, right? You're like, no big deal, I know how to do that. This, by the way, is my asymptote. It's always good to know where your asymptote is. My domain is x is all reals, remember? And my range is y is greater than 0. Okay, in contrast, okay, the inverse of this is this, my friends. Okay, well, when you think about inverse, what was the first thing we do? We switch the x and y's. So my new set of values for this are really 1, 0, and 2, 1. 1, 0, 2, 1. Now here's the weird part. If we're switching the x and y's, then you have to switch the domains and ranges. Your domain is now x is greater than 0, and your range will be all real. So instead of our asymptote going this way, our asymptote goes this way. Remember, we're inverse. So this line goes like this and like this. Now put these over the top of one another. Remember that they are inverses about the line is equal, y is equal to x. Now, friends, I don't want to give you a log and you have to go back and find the inverse. Let's not do that, okay? So let's think about this as really what this is. We are really good masters at writing this in exponential form. So here we go. Remember, I'm going to color code this just like my card here. So here's my 2. All right. So 2 to the, okay, where's my exponent? It's always across. You might say, no, wait a minute, that is really weird. Is equal to x. Okay, but this is in exponential form. This is not the inverse of this. This is exponential form. So remember how I told you that to plug in your values, you plug in 0 and 1 into y? Here's y. See? The y is in the exponent. So 2 to the 0 power is 1. 2 to the first power is 2. That's why our numbers switch. Okay? So now you don't have to go back and find the inverse. That whole idea of going from log to exponent, exponent to log is really super important. All right, so let's try let's kick it up a notch. All right, let's not beat around the bush here. Let's get this knocked out. Now, before, friends, remember that we are always concerned about why things were moving this way, but now we care about things going this way, because right now I'm here. Where am I going? 1 to the right. You're correct. 1 to the right. So I'm going to take my marker and I'm going to put my asymptote. Okay. This goes 2 up. You're right. Any multiplier? Nope, I'm good. Okay. Once you've identified this and this, you need to just take your bare bones here, okay? Here we go. Let's think about this. I'm going to use my pink. So 3 to the y power. Okay, here's my card. Equals, oh, I can't find my orange. X. Okay, my favorite points, 0 and 1. All right, here we go. 3 to the 0 is 1. 3 to the first is 3. And then what am I doing with those points? Okay, well, I'm going to go ahead and I'm going to mark these with a pencil. Okay, and 3, 1, 1, 2, 3, 1. I know I can't be on the asymptote. That's not good. All right, but I'm supposed to go 1 to the right and 2 up. 1 to the right and 2. Right? 1 to the right and 2 up. Okay. There you go. Okay, so what's my domain? Well, I start here and I want everything to the right. So x is greater than 1. Range, that's easy. All reals. All day, every day. Okay? Questions on that? All right, I think we're ready for a decay problem. See, and here's the thing, guys. So think about this. This is really interesting. This is hard to tell whether it's growth or decay, right? Just from this. But if you stop and you think about this, and you think about folding it, all right, folding it. Do you see it? Do you see it? Okay, so what I'm trying to tell you is, remember, if you fold it about the inverse, there's my inverse, okay? So if I take this line and I fold this, do you see it? Can you kind of see it through my paper? Oh, it's totally gross, okay? You can also just look at the base, right? Because you guys were really good at looking at the bases. All right. Here we go. Let's do this. Let's do y is equal to, well, let's add a multiplier just to make things interesting. Okay, so I'm putting this so that you realize that that 3 is not being involved on that, okay? All right, so if the x is not, I'm not going left or right, well then my asymptote stays at 0, okay? This 3 moves 3 down. What does this 2 do? This is a vertical stretch, affecting, right? Well, you know what? Let's see what happens, okay? Let's see what happens when we're putting this all together, okay? Let's see if we can solve for this when we do, kind of when we do the inverse, when you stop and think about this, okay? So think about it like this. If, we're not gonna worry about that, we're not gonna worry about the 3, okay? We're not gonna worry about the 3 at this point, okay, in the exponent form, because we know it's going to end up moving it, okay? So I want to think about just this, okay? In writing this in exponent form, well, the first thing I would do is I take each side and divide by 2. So this is y over 2, okay? Okay. And now let's write it as an exponent. Okay, 1/2 to the, oh, y over 2 power. Well, that's weird. That's doing the opposite of what I think. Huh, interesting. Actually, when you think about it, it's going to have whatever we put in for the y's, and it'll affect the x's. Okay, did you see that? 1/2 to the y over 2 power equals x. All right, let's get our set of points here. Okay, x, y. Remember, I'm putting it in on the y's. All right, so let's plug in a 0 here. So 1/2 to the 0 over 2 power. Well, that's still 0, and that still gives you 1. Okay, would you agree? Okay, let's try this one. What would be 1/2 to the 1/2 power? Well, what's the square root of 1/2? I don't really know that. I should get my calculator out. Here it is. What is 1/2 to the 0.5 power? Oh, 0.7. Okay, well, that's interesting. Okay, so let's graph this. That was weird, wasn't it? So we had to take care of this multiplier here. All right, 1, 0, and 0.7 and 1. So like right here. Okay, and then I'm going to move everybody 3 down. 1, 2, 3. 1, 2, 3. Now, you might be like, okay, what the heck? How am I going to draw this? But you can't come like this. You've got to go, remember, it's a decay. So it actually goes the opposite when you think about it. Remember, if I were to fold this across the equal sign, see, it's a decay. It's coming down. Plus, what's the real big indicator that it's a decay? Right here, friends, right there. If it's less than 1, that doesn't work. That's a no-go. Okay. Let's do the domain. Well, that's easy. It's x is greater than 0. The range, I'm still all reals all day, every day. Okay, so it just flip-flops what we're talking about. Okay, friends, now it's time for you to practice.